going to be programming at 7:15, and then 8 o'clock will be cybersecurity. All right, I want to look at, and I think I should have that right here. Our first assignment that we had last week. Here it comes. All right, here's our first program assignment that we had last week. It was due last night. Hopefully everyone's turned it in. I haven't gone back and checked this morning, but it says list and number the steps needed to make a sandwich. You get to choose what kind of sandwich. Make sure it's at least 5 steps. So that was the assignment. And I want to look at some of the responses we had. So I'm going to pull this up. All right. And I don't know if this was any of your responses or not, because I have 2 programming classes. I just grabbed some of the responses. All right. So this may be you. This may not be you. If I pull yours up here, you don't have to identify yourself. You don't have to say, oh, that's mine, unless it's really, really good and you really want to. So, but I'm just saying, this is just some examples of what you guys have turned in. So let's look at this one. Number 1, grab the bread. 2, grab the jelly. 3, grab the peanut butter. 4, grab a knife. Put the jelly in a slice of bread. Put the peanut butter in a slice of bread. Put the 2 slices of bread together. What do you think? Pretty good, huh? You think I could give this to a robot who doesn't know anything about it and he can make a sandwich? Probably. Maybe. I mean, he might not put the slices of bread together where the jelly and peanut butter face each other. I mean, I guess there's that possibility there with a robot. He might just put the, right on top. But no, that's not bad. All right, let's look at another one. Oh, this one has 9 steps. Number 1, get hungry. 2, walk to kitchen. 3, open cabinet and grab a plate. 4, grab the loaf of bread, open it, and lay out 2 pieces of bread on the plate. 5, open the fridge and grab your sandwich meat and condiments. So they kind of leave it up: turkey, ham, mustard, mayo, etc. 6, put the meat on the pieces of bread. 7, squirt the sauce on both sides of the meat. 7, put both halves together, and now you have a sandwich. 9, eat up. Okay, that's not bad. I will say this is like probably more than 1 step. Grab the loaf of bread, open it, lay out 2 pieces of bread on the plate. So that's probably like 3 steps, but that's okay. We got everything in there, so we can live with that. That's pretty good. All right, let's look at another one. A knife and 2 pieces of bread and jelly and peanut butter. Spread the jelly on one side and peanut butter on the other side. Put together, then eat it. Okay, see, that one's not quite as good. It's not numbered, so we don't know how many steps that is. And what are you supposed to do with a knife and 2 pieces of bread and jelly and peanut butter? It didn't say to get them. It didn't say to open them. It just listed them. Let's look at this one. Place 2 pieces of bread on a plate. Apply ham to 1 slice of bread. Apply cheese to the same slice of bread. Apply mayonnaise to both slices of bread. Close the piece of bread. Okay, that's 5 steps, and it's going to get you some ham and cheese on there. That's okay. Number 1, grab ingredients. Number 2, open them. 3, put them together. 4, put on a plate. 5, eat it. Okay. Can you see differences in all of these? Differences in these. So this one, we grab the ingredients, we open them, put them together. It doesn't say anything about putting them on bread or taking them out of the jar. If you're in one of your ingredients is like jelly, are you just setting the jar of jelly on top of the jar of peanut butter? Here's the point, and let me talk about it real quick. This is just really testing how detailed you're thinking, because when we write a computer program, we're going to have to list every step, because the computer will not fill in the gaps. If we leave something out, the computer is not going to fill in the gaps. So any of these where we're leaving gaps, that's the point I'm making on there. Like this, grab ingredients, open them, put them together. Okay, I'm going to open this, and then I'm going to slap it on something else, the whole jar, right? That's not detailed enough for a computer when we're writing programs. That's the point I'm making with this assignment, is that we're going to have to pay a lot of attention and not assume that the computer knows what we're talking about. We have to list every detail. And some of these are really good. Some of these are okay. Some of these are going to need a lot of work when you get to programming. Let's look at this one. Number 1, bread. Number 2, mayo. Number 3, ham. Number 4, cheese. Number 5, bread. Number 6, pickles on the side. So if we follow those steps, do we have a sandwich? No, there's no sandwich. There's a bunch of ingredients, but there's no steps. There's no sandwich. All there is a list of ingredients. So yeah, we have to detail every step. So that is not steps to make a sandwich. That's a list of ingredients. Let's see. Here's another one. Oh, this one's really long. Oh, it goes on to 2 pages. Whew. All right, because I made it so big. How to make a toasted turkey and cheese sandwich. Grab bread, turkey, cheese, and butter, which could be 4 steps, but that's okay. It's all there. Put a pan on the stove and turn the stove on to medium hot. Put 3 pieces of turkey in the pan. While the turkey cooks, put butter on one side of 2 pieces of bread. Flip the turkey and let the other side cook. Make sure not to let the turkey burn. When you're satisfied with the turkey, take it off of the pan with a spatula, place it on a plate. Place the bread butter side down on the pan. Quickly put the cheese on one side of bread. Roll each piece of meat into an inch-wide roll. Place them side by side on the bread. Let the bread cook for around a minute. Check the bottom of the bread every once in a while. Make sure it doesn't burn. Adjust the heat as needed. When the cheese is pretty melted and the bread's toasted with a spatula, take the piece of bread with the turkey on it and put the plate turkey side up. Put it on a plate, turkey side up. With a spatula, take a piece of bread with cheese on it. Place it cheese side down on top of a piece of bread with turkey on it. Turn off the stove. Cut the sandwich however you want. I recommend 2 triangles. Put the dishes used in the sink. Enjoy. That's got a lot of detail. The person that wrote this is probably going to do pretty well in programming because they're thinking detail. So that's what we need to think about. This one's really good. You know, this one's got a lot of work to go. Some of these are okay. This has got a lot of work to go. This is all right. So just showing you the variety of answers that came in. And that's just some of them. I have a lot more. I probably have 30 or 40 different answers, but I just grabbed a few right there. In Buzz. First thing I want to show you in Buzz. So when you log in, you should be here at our programming class. We can click on that and open it. But I want to point out something. If your screen is dark like this, there may be things that you have trouble seeing on the screen. It's not so bad in programming as it is in math classes, but there may be something you have trouble seeing. You can change this. Up here where it's got your name, there's a menu and it says choose theme. If we click on choose theme, right now it says use a dark color scheme. We can change that to a light color scheme, and you can still pick whatever color you want to be the highlight color. Like I've got the red right here. When I hit save, oh, it changes it to a light background. And so I still got the red at the top that I chose, the red. So the red's my color scheme on that. But that will make it so much easier to read with a light background. Okay, so we're going to go down here to Module 1. You should have done that. We looked on Friday to make sure you could do the academic integrity contract so that you can go to the rest of the course. But if you haven't done that yet, you need to check the box, type your name, agree to those, and then submit and mark this activity complete down in the corner. There's a big button down there that you have to mark so Buzz knows what's. But yes, you need to do this, submit, and then click the button down here that says mark this activity complete. So when you get back to it on this screen, there should be a green check mark showing it's done. All right, let's look at our first lesson. The Welcome to Foundations of Programming doesn't really have a lesson in it. It just talks about this whole unit. So, I mean, you can click on that and look at that, but it tells you all the unit. Here's everything we're going to be doing, about how long it should take you to do it if you go through all the examples and everything, and how many points it's worth. So that's what the Welcome to Foundations lesson is, that 1.00. But we're going to go to 1.01. I can go to the next lesson with these little arrows at the top of the screen. Intro to programming. So every day, programmers write millions of lines of code. Lots of companies have their own programmers. To an outsider, it probably looks like a jumble of letters, numbers, and symbols. But to a programmer, code looks like a way to change the world. Lots of companies have their own programmers and don't buy like software that's available on the internet. You can buy software to do all kinds of stuff in business. But if you can buy it, I mean, scammers can buy it, hackers can buy it, and they can go look at the code and figure out ways to interrupt your system. You know, NWAC got hacked this month. The city of Bella Vista got hacked this month. There's other companies, their hackers are attacking them they're demanding $5 million from NWAC in order to give them their computers back. So lots of companies hire their own programmers and they write their own programs. Those are harder to hack into because nobody knows what those programs are except the programs that work there. So for programmers, this responsibility is pretty huge, but the payoff's amazing. You got the power to change the world. So we're going to learn how to understand the role of the computer programmer, describe different career opportunities for programmers, identify how businesses and people use programming to solve problems, and how programming has evolved. So let's look at these 7 pages of our lesson. So let's cut to the chase. You really want to start writing code. That's why you're in this class. But first, you need to learn the important information about why you're coding and how the programming world has changed. Oh, fine. Okay, let's have a sneak peek. So we are going to use an interactive tool called the Python Guided Activity. All right, so this is a Python coding environment that gives you a chance to write programming and write and edit code. So right here it says, follow the instructions on each slide and complete each activity. Okay, see this Python guided activity. That means this here is actual Python code. And when you run the program with that button, down below is the output. That's where your computer puts the results of your code. Right? And we have one of these we can use anytime. This idle button up here, if you click that, it'll open up one of these Python windows for us. So it doesn't matter what page of the lesson you're on, you can always open a programming window right there. But these are empty. So these are where you write code. You're going to click on that idle button and write your code here. And then when you run it, it'll show it at the bottom. So that's available anytime with that idle button there. All right. This says read the code and try to predict the output. So here's what the code says. Hashtag age calculator. How old are you? Now, let me tell you, when you put hashtag, Python ignores it. A hashtag just means this is a comment. It's not code. Python, you don't need to read this. This is just for people. That's what a hashtag means. When you put the hashtag in Python, that means ignore this line. It has nothing to do with the program. This is just telling people what this is doing. So, age calculator, how old are you? Now, this says DEF. In Python, that's short for define. Define main. So this is our main program. This is the main portion of our program. And then you put little parentheses with a colon. All that's important. Griffin, we're going to meet at 8 o'clock for cyber, sir. So define main. And then notice there's spaces there. You have to indent everything inside your main function. And we'll learn that better. So this says birth year. Oops, I didn't mean to move that. Birth year equals 2000. Current year equals 2016. Age equals int means it's an integer, right? And it's not a decimal number, it's an integer. And this says take current year and subtract another integer called birth year. And then print this year you will be, and notice that's all in quotes. So we're telling Python, print exactly what's in the quotes. Quote this, including a space after the B. That's inside our quotes because we want it to print literally this year you will be and put a space. And then this says str age. Well, we know what age is because age equals. We calculated age right here. We took the current year and we subtracted the birth year. And we told it those are integers. They're not decimals. The str means this is a string. Treat this like a string. That means Python can't print letters and numbers in the same line unless we tell it, I know this is a number, but act like it's just another letter. I know this is a number, but treat it like it's letters so you can print it with these other letters. And then notice there's a plus sign. So print this, plus, print this, plus, and then print another literal string. Literally put what's inside the quotes. Put a space and then years old. So let's run this. This year you will be, and there's the string 16 age. There's the variable age. It calculated 2016 minus 2000, and it printed that. And see, there's that space after B with a space, and then they put a space in front of years. See, if we didn't put that space in there and you didn't think about that, and you said, I want you to say this year you'll be, and then print the age, and then print years old. When we run it, look, it's hard to read now. That's why we put those extra spaces in there, because we need a space between B and 16 and 16 in years. So we put those extra spaces right there. All right, so it's pretty cool. Why don't you play with the code and change the birth and current years? Okay, I'll change this to be Mr. Brock here. I was born in 1967. This is not 2016. This is 2024. So I can change this, and when I run it now, it says this year you'll be 57 years old. So we can kind of understand this program. Very simple Python program. This is a variable. Just like in math, you'd use X as a variable, right? This is a variable called birth year. We put it all together as one word, and it's a variable. And we set that variable equal to 1967. And then here's another variable, kind of like Y equals, but this is current year equals 2024. And so we can change that to whatever we want it to be. Like we can go down here and say, okay, now birth year equals 2007, and then have it calculate again. We can just copy these two lines. Copy. I need to bring that spacing back. See, now I've added, I printed it, and then I changed the birth year. I said, now birth year equals 2007 instead of that, and calculate again and print it again. So now when you run it, it says this year be 57. Oh, this year you'll be 17. Because we just changed the birth year and had it recalculate and print it again. All right, let's look at next. When you see this, a lot of times there's another sample over here. So let's click next. Okay, it looks the same at the start. It says read the code, try to predict the output. Age calculator, how old are you? Define main. Birth year equals, oh, this changed. It didn't say a year. It says input. What year were you born? Input, what is the current year? And then this is the same here. Age equals integer current year minus integer birth year. Print this year you will be. So nothing changed there. One thing changed. These say input now. So what happens when we run it this time? Oh, there's a pop-up window up here at the top of the screen. We got a pop-up window. What year were you born? Oh, I was born in 1967. What year is it now? 2024. Now it says this year you'll be 57 years old. So that way, this program works for anybody because it doesn't have a year. You can just use, everyone that runs it will have to enter their information. Everyone that runs it enters their information. Oh, see, I didn't enter anything. I hit cancel. So now it gave me an error because it didn't have any numbers to subtract right there. So, all right. That was it. That's our little preview of some Python code. Let's look at page 3. And you can go back and play with that program yourself on page 2. Go change things. Can you read this? 0, 1, 0, 0, 1, 0, 0, 1, 1, 0. Here's a whole bunch of ones and zeros, right? This is binary. If you're not fluent in binary, don't worry. But that's what computers read. Computers read binary. So we write code as a programmer that will translate commands, which is like print and, equals, all those, to binary. Python takes what we write and translates it to binary so the computer can understand it. And here, if we want to read what this says in binary, it's actually saying, I am awesome. That's what this says in binary right there. So you can have your shirt printed up with all that on it, and you're saying, I am awesome. Perfect. Here's some things you might not know about computer programmers. One thing, they're inventors, because you are inventing a program that does something, sometimes from scratch. Sometimes we take other programs and modify them, but sometimes from scratch. And this helps power every industry in the world. Every industry in the world is run with computers. They're fluent. Like when we talk about people being fluent, usually they can speak English and Spanish or French and all these other languages. Well, a lot of programmers are fluent in thousands of different programming languages, not each individual one, but altogether, people are programming in thousands of different languages. And each has a different set of rules and meant for a different purpose. Now, most time a programmer will specialize in one language, but it's likely that they know a few others. So you know Python, but you can learn other ones very easily after you understand Python. They're visionaries. They don't just write one program and move on. They write multiple programs. Every time they find a need or a problem, they write a program. And they're gatekeepers. They write and they own that program. So they got to test it, debug it, which means finding the errors in it, and then resolve it, and then update it from time to time when they say, oh, this also should do this. They're also researchers. There's code libraries, programming threads, and collections of best practices that programmers seek out to improve their skills. All right, page 4. Can I be a computer programmer? Yeah, everyone can. Absolutely. Computer programmers can be men, women, old, young, any part of the world. People from all walks of life have contributed to the programming world, even models and sports stars. Here's Lindsay Scott. She's a runway model. But before she became a model, she learned to code. She started creating her own games on her TI-89 graphing calculator when she was in middle school. She's created several mobile apps that are popular and also is a model. And then NBA All-Star Chris Bosh played for the Miami Heat, known for three-pointers and rebounds. But before that, the player with the 1 on his jersey had another interest. He also wrote code, so he knows how to write programs. Who was the first president to write code? Well, Barack Obama wrote code, has written code. So everyone can be a programmer. Teen programmers. In fact, some of the most innovative computer programs today are teenagers using code to jumpstart their careers and change the world. Here's a few of them. Here's Trisha Prabhu, an 8th grader in Naperville, Illinois. She programmed the Rethink Alert. This combats cyberbullying by alerting people that their posts on social media may be offensive and gives them a chance to stop and think about it, and maybe they want to change it and write something different. Here's Michael Saman, who at age 12 learned to code. And by age 17, he created 4Snaps, which is a multi-user photo game that took off in the App Store. And Facebook took notice of it and offered him an internship. He now works there as a software engineer at Facebook. Software, programs written for computers to do things. At 18, Brittany Winger, a native of Sarasota, Florida, built a breast cancer diagnosis program that changed medicine. She was inspired by someone in her family that got breast cancer. So she researched, programmed, and tested a program and able to detect 99% of life-threatening tumors through a computer. And she won the Google Science Fair in 2012 with her program to detect breast cancer. Teenagers, making a difference. So you can learn the code and do that. So what do programmers do? Well, short answer, they write code that tells computers what commands to follow. So they solve problems with their code. So the important details. Back in the day, programmers used code to perform calculations, and they did all that manually. Code ran on huge machines that would be the size of a room that required turning large gears by hands. The first computers, you had to hand crank them, flip switches, attach wires to different places to make it do different things. And it could take days or weeks to run the whole program just because you had to do all the manual stuff. Well, today it's a lot easier. Well, physically a lot easier. But the things programmers can accomplish gone far beyond what they used to be able to do. These modern day superheroes not only give us the ability to Snapchat, somebody wrote that code, but they're also present in nearly every industry that exists. You name it, they'll code it. Another task programmers perform is writing software, which again, that's programs written for computers to do specific tasks. That's the term we use to describe the interface that allows communication between human computers. A mouse is an interface, a keyboard is an interface. Remember the last time you had to write an essay by hand? No, you probably don't. You write it on a computer. You can thank a programmer for that because they wrote a program that allows you to write your essay on a computer. Someone wrote Microsoft Word, someone, all these different things. Software is your go-between, and computers create that. So think about this. Programmers actually write new software with existing software. We use Python, which someone wrote, in order to write other programs. Because of this, programmers have one of the most powerful jobs in the world. So what can they do? Healthcare. Computer programming has revolutionized the healthcare industry, making it more powerful and efficient than ever. There's patient portals, there's robotic surgery, 3D printed prosthetics. None of this would be possible without programmers. You got education. The education industry depends on cutting edge software. Someone wrote Buzz, this platform, the website that we use, to help students stay in front of today's technology. A programmer wrote your online class. Military. Computer technology has easily become one of the most powerful tools in the military. They rely on programmers to develop drones, maintain operational security, and cutting-edge technology. The tech world is made up of programmers who make tomorrow's technology possible. From building social media sites to building talking smart cars, programmers are changing how we experience the world. Because, they have those self-driving cars now that programmers are a huge part of making work. Entertainment, films, video games, concerts, more, all use programmers to create the effects we enjoy. That Taylor Swift tour she's doing where she's got that huge stage that has all the digital effects. Programmers wrote all that. She had to hire a bunch of programmers to get that working. Agriculture, that's come a long way from the days of early planting. Software created by programmers helps track and plan growth so we can have the healthy food we need. Very involved in the agricultural area. Construction, our architectural industry makes heavy use of programmers who allow for amazing new accomplishments in building and construction. They write the code that makes a mock-up of buildings, maps out land, all kinds of stuff. And adaptive technology. People with disabilities rely on programmers to create software to overcome daily obstacles. Screen magnifiers, touchscreen displays, speech recognition software. That's among many other features which allow people to perform daily activities better. So lots of different things. All right, page 6. Where did programming come from? It's probably a lot older than you would guess. Check out the timeline and see. So here's today. Gaming, hacking, developing code, that's part of the everyday world. Everyone around you either building or interacting with programming on a daily basis. You're on your phone, there's a lot of programming there that made your phone work the way it does. Programmers today work in every industry imaginable. Thousands of different programming languages out there, all developed to meet a different need. We need a program to be able to write this. We may need a new language to be able to write a program to do that. Mobile devices and constant need to access information means a higher demand. So that's today. If we go back to 1981, MS-DOS was released, Microsoft DOS, allowing people around the world to use early operating system for the personal computers. Windows had not been created in 1981. It was not on your computer. There was no folders. There was nothing to click. You didn't have a mouse. When you had MS-DOS, you didn't have a mouse because that's part of the Windows program is written. Pulling up files meant typing commands. Everything was typing commands. That's all you did on the computer to make it do things. So the era of the personal computer brought programming into the commercial world. That's the first time you could buy it at home. Programs were written so users could type simple commands to open, close, and run applications. 1968 to 69, Nicholas Wirth designed the famous programming language Pascal, which is still used today, in his 30s. The development of Pascal pushed programming into a new era, past just calculations and into a more sophisticated type programming language. It was in 1957. John Backus developed the first programming language at IBM that's still in use today, called Fortran. Another programming language, Fortran. The language has evolved to perform highly advanced calculations. It's fast and effective at completing tasks. So as computers got more advanced, so did programming. Programmers developed new languages so they could translate commands into binary or machine code. See, that's a card. You had to have a card reader, and this is how you'd program. I did some of this in high school as an experiment. You had to punch out different little spots on that card, which meant it was a different command. Instead of typing in the computer, you didn't type it in yet. You had these cards. And so programs were written on that. You would punch out little holes and then feed that through the computer, and that would tell it what you wanted it to do. Crazy. Let's go back 11 years to 1946. The electronic numerical integrator and computer called ENIAC, which was designed for the military, was the first electric general purpose computer. It had 17,000 vacuum tubes. I've worked on a computer that used vacuum tubes. It was very old, but I got to use that in high school. The creators named it ENIAC, the Giant Brain, and looked at the size of it. I mean, it's huge. Programmer's job involved physically turning gears early on, flipping switches, attaching wires. Now let's go back 100 years to 1842. Ada Lovelace. She was the son of Lord Byron, for you literary people. Ada Lovelace wrote the first computer program in 1842, even though computers didn't exist. She was dubbed the Enchantress of Numbers by Charles Babbage, the inventor of the computer. Yeah, Babbage invented the computer. She's known as the first programmer. Programming mostly existed on paper. They didn't have a machine to do that, but she wrote something that was basically recognized today as a program. She just wrote on paper. An algorithm to compute numbers. So it's pretty cool. So programming's come a long way. It was used to be something only a handful of people dabbled in. Now it's all over. It's an in-demand skill for many careers. So here's a little profile of Ada Lovelace. She lived from 1815 to 1852. Died at the age of 37. Not that uncommon back in the early 1800s. Known as the first programmer in history, she wins the award for most intelligent. She wrote an algorithm that would compute Bernoulli numbers. It's a sequence of signed rational numbers, can be defined by an exponential generating function. If you want to get into the big math stuff, there you go. Before computers even existed, her early work provided the foundation for computer programming. She was the daughter of the famous poet Lord Byron. She was encouraged to study math because her mother feared she would inherit a passion for his words, which she believed made him insane. Because Lord Byron went insane, and mother thinks it was because of his poetry, because that she wanted her daughter to get into math, stay away from all that literary stuff because it'd make her go crazy. All right. Page 7 just says, make sure you read the lesson. You can practice on that Python page on page 2. And then let's do the assignment. Let me look at the assignment, show you what it is before we get out of here. Look, you have 3 attempts. 3 attempts. So you go here, you have 5 multiple choice questions worth 25 points. First couple of weeks, we just have some multiple choice questions. We will start writing the program soon, though, so pay attention when we start learning about the commands and how to use Python. And go practice on page 2, get a little bit familiar with Python, and we'll be writing programs very shortly. But that's your assignment. You have these 5 questions to answer regarding the lesson we just looked at. And if you've turned in the assignment from last week, I'm going to be entering them in the grade book today. Then you've got 10 points. You've got 100% in the class, and you won't, you won't have to be. Well, let me talk about Wednesday real quick. I need to point this out. Wednesday is the last required day because we the first 2 weeks of class we meet every day. Since we had the boot camp on the Wednesday, we didn't meet. We started on Thursday. So Thursday to this Wednesday. However, I am not here Wednesday. So in order for you to be counted present Wednesday, because you have to come Wednesday, I'm going to put an assignment in Google Classroom, and it's not a programming assignment. It's something you have to go fill out, basically saying, yes, I came to class. Okay, look for it in Google Classroom. It'll be like 3 or 4 questions. You go and fill that out, and you won't be counted absent. If you don't go fill that out on Wednesday, we'll come in Thursday. Everyone who didn't fill that out is absent on Wednesday. So if you want to be counted present Wednesday, all you have to do is fill out the Google form. And you don't have to do that at 7:15 in the morning because I'm not going to check it till much later. Just make sure it's done on Wednesday because I'm in Little Rock. I have to have my ear checked up. Follow-up appointment on my surgery I had. So I'll be in Little Rock on Wednesday. But, this is not an A day. I got to change that. It's a B day. So Thursday and Friday are both B days. We won't meet either day, so we won't meet again. Yes, Sierra, what you got?
Isn't this the start of the asynchronous days?
Yes, but only Thursday and Friday are asynchronous days this week because Wednesday is still the end of the 2 weeks. Our principal wants us to still have class on Wednesday because we had boot camp that first week. So
thank you.
That's a good question, though, because normally I wouldn't even think about Wednesday this week since Thursday and Friday are asynchronous. And next week we'll actually meet on Wednesday, but only because Monday is Labor Day. We don't have any school on Monday. So Tuesday and Wednesday will be the days you meet with class, and Thursday and Friday will be asynchronous as well next week. So, all right, guys, I'll let you out of here. My cybersecurity will be coming in here any second. I'll meet with him. Have a great week. I'll see you next Wednesday since Monday's a holiday.